It's time we learn more about how we can create arrays from existing data. Imagine you have this array, which will equal an NP A range, which goes up to 10. You can create a slice from this array using the following syntax. Array slice equals array from 3 to 6. Next, we're going to print the array, which will equal the array, and the array slice, which will equal the array slice, so that we can see them side by side. Right now, if we were to run this, we'd get back the original array and the array slice. Here's an important detail though. When you slice a NumPy array like this, you're actually creating a view of that slice, not an independent array. This means that any changes to the slice will also affect the original array. And this behavior can be quite surprising if you're expecting a completely separate copy. So just to show you what I mean, I'm going to type in array slice at the index of 0 equals 999. Then I'm going to copy this and paste it directly under, so that when we run this, you'll see the changes. Here's the slice that we thought was independent when we created it, but as you can see, as soon as we change something in our array slice, which is just a view, it also affects the original array. And most programming languages do this to optimize performance. Copying data is considered to be an expensive operation, so many languages require you to be explicit when you actually want to copy the data. And we'll come back to this in just a bit so I can show you how you can actually create a copy in case that's what you want. But next, let's take a look at how we can stack arrays in NumPy. So to get started, I'm going to create these two matrices so that we can use them for the example. And the very first thing we're going to do is stack both of these horizontally. So to do that, we'll type in np hstack and pass in A and B. And when we run this, what you should notice is that we will end up with a matrix such as this one. It stacked them horizontally. And just like with hstack, we can use vstack, which will stack them vertically. It's as simple as that. Now going back to the first example where we created a slice of data from an array. As I mentioned earlier, what we did is create a view of the original data. So here if we type in array equals np a range and pass in 10 once again, and then type in array slice just like we did earlier, and say that that's an array slice from 3 to 6. And then at the index of 0, we change it to 999. Once again, if we print this data, we're going to notice that this operation over here affected both of the arrays, because once again, this is just a view. It did not copy that data, even if in vanilla Python, it would copy it. And once again, the reason NumPy creates a view is because it saves memory and is much faster than copying the data. If you actually want to create an independent copy, you can use the copy method, which will create a deep copy of your data. And to do that, you just need to add the copy method to whatever array you want to copy. So here we're creating a view and then we're copying it, which means that when we try to change an element in the array slice, it's only going to affect the new array and not the original, because now we're working on a deep copy. Each one of these arrays are unique. And just note that this one behaves differently than the one that's built into Python, because the one that's built into Python performs a shallow copy, while in NumPy, it performs a deep copy.